Making fusion videos on things. What to do a thing, What the hell is a KiCad folder doing in my fusion files? Well, I just finished doing the last KiCad video on making footprints and libraries and all that, and then I was poking around a little bit. I thought, hey, we made some footprints, we made some schematic symbols, been doing CAD videos and things like that forever and ever, so what about the 3D shapes? That's got to be not such a big deal. Well, as it turns out, looking around the web, there is a lot of old information on how to go about doing this. And I don't really want to address any of that stuff. And maybe this is not relevant. This is absolutely relevant, but maybe there's things that other way can do, but I'm not going to do it because it works out just fine like this. With the release this past year of KiCad 5.0, they now support IGES files directly, so you could just export out of your good old CAD package right into an IGES file or a step file, and you can bring it basically into KiCad, and you can use that for your 3D shapes. You guys that might be watching this because it's Fusion and don't know what the hell KiCad is, it's an electrical design automation software. It's a CAD package for electrical, right? And inside of that, you can do your schematics and you can make all these little shapes and thingamabobs. But at one point, you can look at your PCB with all of your components on it, as in, some height there, like a 3D design, right? And so somebody has to make these models somewhere or another to get them into the system. And if you want them to look cool, as you can imagine where I'm going with this, you maybe might want to do it yourself, okay? Now, the other reason that for you non-KiCad people, that you would want 3D design shapes rather than just to look cute inside of your EDA program, you want to know the height and the sizes of these things so that you know if it's going to fit with inside of your package envelope, as in the box or thing that you're putting it into. So what I've got is this. The old documentation ran through a handful of different programs, FreeCAD, derp, a couple other derps, and into something else, right? I can't remember. But to get to a file that you could get into KiCad, and I feel like maybe there might be some reasons for the complexity that I'm missing. But what I'm going to do is show you what I know. You can go into your CAD program, and especially because of Fusion 5.0, with the release of 5.0, they now will take, you can import an IGES file straight in. I'll go over here, get into my new KiCad folder, open that up. There's nothing in here. So I have this new document. Now, when it comes to making assemblies in Fusion, what you want to do is you want to save it first. And so this is going to be, if you want to, or if you did watch my Fusion video on footprints, it's that same exercise. We're going to do a TO220 package. And if we want to get specific, because maybe we should, it's a TO220. Let's just say we're being specific. It's an 1117, and if I want to be even more specific, it's from ST Micro. If you're going to make a lot of these, you want to make your name specific. I kind of said this also in the other video, but this has kind of a different reason. You might want to make, you guys that are good in Fusion, maybe you want to help out the electronic community, and maybe you're looking for something to do. Go get yourself some data sheets, and let me grab this one over here. I'll bring it over and show you. So this is kind of an example of a page off of a data sheet that shows you the dimensions for the electronic package. And then there's usually a chart that goes along with it that specifies what those callouts would be. So if You want something to practice on. If you want to do some real life stuff, model some of these things up. Start yourself, a Bitbucket GitHub account or something like that, some place to store all these things, and be a bro and save all these things up there for everybody else to get at. That'd be kind of cool. Boom. Okay. TO220 ST 1117. It's a 3.3 voltage regulator. So we'll hit OK. Get that in there. Now this is going to be the assembly. This is the whole assembly. Well, it's taking a little bit to save. So there we go. Once it gets saved, now you can start making the rest of your components. So just right off the bat, if you know what you're doing, go ahead and make some new components. So this first one here is going to be called, we'll call it tab, I guess. And then the next one here, we're going to make a new component again, and this one's going to be called body. And then we'll make another one, and it will be called pins. Come on. Okay, pins. You see? Okay, so we'll go over here and we'll create the tab structure first. That seems to be the easiest. Now, when you're working with assembly, a thing that Fusion does is, if you're used to doing things like up to last, or you're making a whole extrude cut and it's going through things and you say through all, it is conscious of the fact of the other parts in the assembly. So if you've got all of these lights on here and you've got multiple components visible here is what I'm getting at, and you're working, even though the dot is say on tab, but you make a hole in it, you say go through all, that hole is going to go through all of the parts that you have, all the components in its path. So make sure that you unhide and show and hide these things as necessary. I'm going to go ahead and start in the tab here, and I'm going to knock this out pretty quickly. I'm not going to make this a major tutorial on how to use Fusion or something like that, and I'm also not going to probably follow a lot of my own rules as far as linking to other objects. If you've watched any of my other Fusion series videos, that's a big point all the time. This would be one of those times where I'm going to kind of break that rule a little bit. So this is going to be a guideline to start out with here. I'm going to make this about as big as the part is. So it's about 15.5, 16 or so millimeters tall. And it's about 10 wide. And I probably should have turned on construction element before I started there, but oh well. We'll go like this. We'll hit that or hit the X. So now I've got a guideline to go off of, and I'm going to create now let me bring this over here. I'm going to create the tab. Here you go. In this picture right here, I'm going to create this tab structure, and as you can see, it kind of fits inside there. You may never see this, right? But this is just for, the whole thing is really aesthetics for the most part, right? So I'm going to put this in here, and this is going to be laying down on the PCB, so you'll never see it correct, except I'll probably use the same model and just straighten the legs out if I ever want to have a TO220 standing upright. Okay, so I'm going to do it anyways. Then I'll grab a line tool here, and I guess I'll just go off. Yeah, well, okay, here's what we should do. I was going to use the middle line as a guide, but H1 right here, H1, the distance is, let's say, 6.5 millimeters. So I will draw, I'll just start drawing here. So I'll draw a line from here to here, here to here, etc. Okay. Now I will take these two right here, and we'll make them collinear. I don't really think this out a whole lot of times before I start mashing buttons. There's always a bunch of different ways to do this. So that's good. They're where they're supposed to be. Now this gap distance, we don't have any dimension on that, so I will just, what is with you? Okay, so I'm going to take this here, 1.5. That seems, yep, that seems okay. And then we'll take this one over here and make it the same as that one there. You see, formulas. We'll take this one and we'll do the same thing from the bottom so everything looks okay. You see, it goes like that. All right. And we'll take that out and extrude it. I'm going to be mindful of what's up in the air. We'll bring that up and we'll make this 1 millimeter. If I go back to data sheet over here, the thickness right here is F. That should be probably about the same as C, not necessarily, but F is, okay, so about 0.6, so it's even a little bit thinner. Wait, was that a big F or a little f? Big F. Okay, so let's shrink that down a little bit. 0.6, seems good. Okay, now in no particular order here, we'll grab a chamfer, put a chamfer on the corner here and over there. Bring this in a little bit. There's no dimension on that, so we'll take a guess. We'll say 2, looks good. So then over here, our hole, we got a diameter of P, and it is down by Q. So we'll go over here. The diameter is, it's a 4 millimeter hole. It's for an M4 fastener. And Q is, let's say, 2.8. How about that? We'll go with 2.8. Give me a center line to go off of here. Just kind of have it. Four, and this right here is from the top here. Is that what it was? 2.8. Extrude that through and through all. Okay, so there is the tab structure right there. Then seems okay. Then we'll go over here to the body. I will just grab all of this right here, and I really just need one of those. Project that forward, so I've got that. I guess I'll make everything a construction element. And then I will grab, I'm going to use this rectangle right here. So the 3-point rectangle, this is nice for things like this where I can go from point to point, and then I can bring it up. Should have done it the other way. From here to there, and then I can bring it up to there. You see? Why is that blue? Oh, it didn't stick. Okay, we'll make that collinear to that. And then extrude that up. Now that is A. So A is about, let's say, 4.5. Seems kind of fat, but that's what it says. All right, I'm going to roll this over onto the back side here. I'm going to hide the tab temporarily so I can pick this bottom face easy. I'll pick that, go into sketch on the bottom there, unhide tab, and catch just that edge there. And I'll project that forward, and I'm not going to make it a construction element. I'll just leave it there. And then we'll grab a line tool, go across there, and then we're going to extrude this up, extrude cut. But oh, hide tab. This is a thing with this, right, that it will cut through the tab and the body, even though it's an assembly, different from other programs, it will cut through it. So unhide tab, and as a matter of fact, I'm not certain all the time that it didn't keep that in its mind that it needed to do that. So come back here, unhide tab, then hit extrude. Test that a little bit if you want. And then we'll say minus 0.6. And so then that has the same cutaway for the tab to fit into, or at least, you know, it looks like the actual part does. Then the next thing that I want to do is create a little bit of a draft angle on some of the sides here. for looks, and also I figure, you know, anything that's going to be a molded part, it usually has a little bit of a draft angle in it, so you can pull it out of the mold. Now, a couple different ways to go about doing this. So I'll just show them both really fast. I could do a draft right here, but if I pick draft and then, oops, didn't mean to do that. If I pick this as the face right here that I want to draft, and as a matter of fact, I want to draft all of these around here like that, then the plane could be this plane right here. What will end up happening is it does draft. It bends. Can you see pivots on that plane right there? But you see, I don't want this other bit here sticking out, right? And so in, say, CATIA, other programs will have, you know, parting elements and limits and things. You can just say not to do that. But the way you do it here is you pick two sides and just leave that side at 0, and it'll get you the same effect. And then you can bring this back, and we could tilt this at, say, you know, yeah, 10-degree angle. Seems pretty good. Okay. Now, I'm going to cancel that and wait for it to wake up. And then I'll show you another way you can do this. You can do it with a chamfer, and this is kind of neat. You can pick all of your edges here. Now, your typical chamfer is going to be kind of a 50-50 split as it comes down like this, but you can pick two distances, and now I can say I want to come down so far and in so far. So essentially having the same kind of effect as the draft that we just had. Now the deal here though is you don't get to pick this down here, so that's a little bit more of a pain, and you don't want to eyeball this, so you just got to know, you know, it's going to be 3.9 because this was 0.6, was that what we had there? So math it out, I think we ended up with a 4.5 total, I think is what the deal was there. Okay, and I guess since I'm here, we'll just go with this. I'll bring it out. They don't tilt terribly too much. How about we go with 0.5? Seems fine. Okay. Getting close, getting close. So I think that's good for now. We'll go over here to the pins, and this one's going to be a little bit trickier. Part of the reason, by the way, that I didn't draft the back end is I'm actually going to pick that back face to build off of, and I didn't want it to be at an angle. So I'll grab myself a line, put my line up here, and make that a construction element. And then we got to make our pins. And let's bring this over here. In the previous video, I mentioned about like this particular package has got these little notches right in here, and I thought how they might be used for bending, and I think that that's probably true, but honestly most 220s or most packages like this, you're probably going to bend the pins out here and have this length be sticking out. It's kind of up to you, but if you're designing a footprint and you're designing something like this, a 3D model to go in that footprint, you know, this is just looks, but the footprint itself, you know, you kind of got to decide what you're going to do. Like if you're going to grab it with your needle nose, say like right across here, sometimes I'll just grab the whole mess with the side of a needle nose and just bend them over. And so it kind of bends from like right in, you know, right in here around there. A lot of these don't have these little notches. They're just straight wider sections coming out. Anyways, it's a small, stupid thing that you kind of got to know what you're going to do. So, because it'll tell you what the dimension is, how far this is going to stick out, as in where's the hole going to be on the PCB. So if you're going to bend these down, then your hole is probably going to be right about here. But if you're going to bend it right in here, then your hole is going to be about there. Watch that other video if you care about stuff like electronics and such, KiCad. Talk all about that. So I think what I will do is we'll just kind of do a guess. Now, what we do want to know, though, is this dimension right here. See this J value? This is how far up the side of the package we need to put that pin. So J1 is 2.6. We'll say 2.6 right in the middle. And I'm going to go with a centered rectangle. Don't know if you guys use those a lot, but they're very nice. And then the dimension was from the bottom, right? So make sure you pay attention to that. So to show again, or what is it, 2.6, you see? Right, then the pin dimension itself, if you don't want to map it completely perfectly at this point, this is okay. It's kind of nice to have the idea of the fat and then to the skinny, but so yeah, we'll do that a little bit, but I'm going to skip this little tiny section in here. So then if you look here, our B1 value is right here. So 1.5, we'll say. Okay. And then the thickness, I thought I remember this from before. I think it was 0.6. C is, yeah, we'll go with 0.6. Okay, so there is our pin. So now you might be wondering, why am I drawing this on the side like this if I'm going to bend it over, right? Well, this is going to be, we're going to create a sweep. So sweeps are, this is perfect for this. It's not just for tubes. So take this, we'll go over here to this side plane, and then grab a line tool. A couple things are going to happen here now. I'm going to snap to this point, click, and I'm bringing it out like you would imagine. Now, you might not know about this, but don't click. Get it straight and then just hold it down. I'm holding it down, and you see how I'll make a little curve. I'll bring it out here, somewhere out here about like this. Let go, and then zoom out and bring it down. If you want to make it tangent, it's kind of either or. You bring it down here and then clip that off. So it's tangent, so I don't have to make the tangency, but it's not straight, so I got to make it straight. So whichever one suits your fancy there. But we've got this corner on here now, and now we can dimension that. So now we can go from here to here, and we can start calling out things. Like I think that might be about 2 millimeters, and then maybe we'll make that one 1.5 radius. Something like this. Take that, straighten that up. Okay, good. Now, this dimension right here is where the center of the hole is, should, could, would be, right? So if 2 millimeters isn't good, adjust, all right? So we'll exit out of here, and we've got our components. Incidentally, this length right here, we might come back and change, because this is going to be the end of the pin that's going to stick through your PCB. So if you want to have the pin go through and just be poking out just the perfect amount, then we'll shrink this up. If you wanted to go so far as to put a little blob on the end here that looks like it's soldered, you could do that too. So we'll come over here, we go sweep, and with the sweep you need the two things. So we need a profile and a shaped, a path to follow. So you do that, and you pick that, and then it goes like that. You see? So that is kind of getting set up for the idea of our pin. Then the rest of it, I figure this bend radius is kind of where that fatness would be. And so we'll come here onto this face here. And how about this? We'll just grab, yeah, we'll just do it like this. We'll grab a rectangle. And how about we do a projection first? Yeah. So we'll grab this. We'll go here, we'll go there, we'll project, enter, should have made it a construction element. Good. And now our rectangle, we'll go from here, doesn't really matter, something like this. And now we could do another one, but just for the sake of using tools, we'll grab a line here, and it really doesn't matter where you bring it up through or down or all the way through. Really wish the Fusion people would fix this. Allow me to pick a plane or something like that that exists in the background, so I don't have to do this. I am going to go here, pick this, pick this. I think it's probably worth, debating whether or not it was easier to do this that I'm doing than it would have been just to draw another square. But it ties the two together. So you see I'm going to do a mirror. I got the elements there. I'm going to pick my mirroring element right here. It's going to put them right there. Okay, now I have them constrained on the edges but not through the middle. That's intentional because my dimension is here not the side widths over here. So the pin, let's say 0.6. That seems like a pin. I won't even check the data sheet for that. That just looks okay. Now these here, do you want them to be flat? Are they just chopped flat? Or are they square? How do you want them to be? I really kind of don't completely care right now, but I do want them, I don't want this any lower than the bottom of the device here. So if you want, you could even grab this and just make it collinear with that. And then that's kind of like the perfect fit. The fat, thick end here bends over, hits right down at the base of the PCB, and this goes on through and you solder to the other side. Boink, boink. Bring it all the way through all. Oh yeah, look at this. See this? It's going through all. Even though there's nothing there, it's going to the extent of the tab. Not intentional, but that's what I've been talking about. So you uncheck, well, the pins don't, body, there. Okay, so just the pins. Then extrude, hit that, bring it through up to all, through all. You see? Now we're good. So there's our pin. We can bring back the body so we can at least see what's going on. Then what you do is we're going to make a pattern. So you go to pattern, rectangular pattern, and you change it from faces to bodies, right? Because this is a whole body here, so that's good. So we got that right there. And instead of extent, we're going to say spacing because the data sheet has a spacing. And then our direction, I'm going to use an axis. That's out of a habit rather than an edge of something else. I don't want to keep making links to things, I guess, if I don't have to. This is all going that direction, so I'm going to say symmetric. So one goes this way, one goes that way. And then we'll go grab, where's my data sheet? Data sheet. So our spacing on the holes right here is the little e value. And little e is about 2.5, 2.55 if we want to say that. Hey, look at that. We're pretty good. 2.55. Look at that. We've got some pins. Then I think what I'll do is go back to the part of the profile, or I mean, sorry, the path right here. And I'm going to shrink this up to, go right here, from here to the bottom. And I figure if we had it stick through like maybe, I don't know, maybe a millimeter or two, and say the PCB is, 2-3 millimeters. So if we change this to 5, maybe that will look okay. That looks like it's going to be kind of thick. Let's say 4. Yeah. So that will be our set of pins. Now let's unhide everything, and we're almost done here. So there is our component, you see. But before we call this done, we need to make it look. It's got to look better, right? We've got to add some color to this. So we will, I guess for the sake of clarity, we'll hide all the other things here. Hit A for appearance, and this right here, I'm going to make it be kind of a glossy aluminum, I guess. And then you could edit it, and we could make it be a little bit brighter. So that looks pretty good. Nothing real important there, but that seems to be fine. And then we will unhide our pins, and then let's go ahead and do the same thing with them. Yeah, what the heck? We'll do the same thing. Now these are for all the bodies, so I got to drag one out on each here. There you go. That looks nice. Good. They didn't even have to be a different color. And then the body right here. Well, before we go ahead and color this, let's fix it up a little bit more. So we'll go and we'll add a fillet, because fillets are always nice to kind of add a little bit of a finishing touch to things. And I'm going to go ahead and put a fillet around all of the edges, but not very much. Just these outside edges here. And let's try like 0.1. How about 0.2? That might even be too much. Yeah, I know it's kind of picky. Just want to have like a little bit of an edge break. Oh yeah, that's way better. Okay. Anyways, so we have that, and then we got to do this. We got to do this. You come up here and make sure you're looking at it the right direction. So you see the tab will be coming out the top there, up here, and we'll add some text. So we'll put some text right here, and then you decide, do I want this just to be the generic TO220 package, or do I want to write something specific on it for the actual part that it is? Whoa, okay, get there. There you go. And let's try 2 millimeters. That seems okay. And I'll put it right about there. Seems okay. We'll hit extrude, and we're going to put this down into it just a tiny little bit. Just how about that? Minus 0.1. That seems fine, because what we're going to do next is add an appearance. And this one here is going to be not aluminum. We're going to go with plastic, epoxy, basically. We'll go with opaque, not glossy. Let's go with a matte. Where is it? Where's oh, there it is. Matte black. Yeah, there you go. There's our TO220 package. And then we're going to switch over to faces, and we're going to say plastic glossy. Sure. How about a matte white? And you better zoom in because it's kind of hard to get at. Come into here and you get right over there. You see what we're doing? And then don't grab another one. Grab this one up here because it'll always be this one. And if you want to change the color a little bit, you only have one to change. Actually, I think it probably would just leave the same one there. Oh, there you go. Look at that. So unhide all the things, and there is our package. See? Ta-da! Awesome. So that is done with the first half. Save it, save it. Holy crap, should have saved this a long time ago. Save the thing, and then we have to get it over to KiCad, and that is not hard. All you have to do is come up here and you go export, and then you say save to my computer here. And if you didn't know this, because I've heard some people say, oh, it's a bummer, Fusion's only online, too bad you can't save it to your computer. Well, yeah, you can. You can save Fusion 3D to your computer if you want, just like all the others. But here, when you hit the drop-down menu, change it to step, or they do IGES files now. So you say IGES, and you hit save. The things I've read online, whether they be true entirely or not, because, you know, it's just in forums, is they're talking about how you would want to make things in an assembly like this because you can't apparently color faces so well. Just some brief little glimmers of things that I've read. I have zero idea on how true, accurate, or whatever any of this stuff is. Well, I can tell you with what I just did here, make this, everything is a body and they have its own color, but this is it's colored as a face. It will work out just fine. Is that crooked? Nah. Okay, so exported, done, saved. Let's close this and get over to KiCad. Whoa, did I just say KiCad? So this is KiCad, for those of you that don't know. This is an electronic design automation software, and it's for designing circuit boards. So it would start with a schematic right up here, and you'd create your schematic, and from your schematic, you would turn it into a PCB, printed circuit board. And, well, to show you this, for right now, this is kind of the rough idea that we had from the previous video of maybe a circuit you might make, and you would wire it all together. This thing right here is the logical symbol of the thing that we just designed the physical component for in Fusion. Now this right here can open up what they call a footprint, which I'll show you. There's nothing there, but I'll show you. This window over here is ultimately where you would see again, all those same components that were over in the schematic, but they would be the holes and the pads for the physical item that would be actually, this would actually be the circuit board. So all the dimensioning would be accurate here. If the thing was a big component, it would take up a lot of space. If it was a small component, it would be small, right? So we haven't gotten that far yet, and that was actually one of the reasons why I stopped to make this video, was because I have the footprint, so I'll show you that. So again, schematic symbol, and then if I go here and edit this, what I can do is I can go right here and I can show you the footprint. You'll kind of recognize it. So it's the PCB footprint. Down here is your pins, labeled correctly. Everything matches with the data sheet. This is a hole that will go into the PCB, drilled through, that you'll put a fastener in. And this is kind of the rough outline of the actual item. But again, it's just the stuff that's printed on the flat circuit board and the holes in the copper that the holes that go through in the copper that's placed on it. Then closer to our point, why we're here, one of the things that KiCad has the ability to do to help the electronic designer visualize their board better and be able to see, you know, spacing and how things are going to fit inside of, say, a case and such, they do have up here a 3D viewer. And it is actually very convenient. It's cute, it's nice, but it is actually a very important part of an EDA tool. And now if you roll this around, as you can see, it took what we did, what we did in a previous video about making that footprint, and it has the silkscreen trace on here, it has the copper pads you can see in red down here, and the holes that do go through here and up here. The big obvious thing that's missing is the actual component itself. And if you're going to take this and you're going to put it into a box and you're trying to eke out all the space possible, when you're putting this in somewhere, you might want to know how tall the component is before, you know, you go just building a case up and hoping. So I'll go ahead and close this, and I'm going to, well, I'll even close this here because I'm going to jump right into the PCB and we're going to add a footprint. We're not going to do any routing or anything like that. This part right here, we're almost done. For everything that we just went through with the Fusion stuff, getting the thing developed, that was definitely the hard part. All you have to do here now, you don't have to do any other conversion process or anything like that. You're just going to go to your PCB. And, you know, theoretically, your circuit board, your schematic would already have been routed, and you bring in the net list is what they call it, and then all of your components would be laid out here in that footprint style that we're just looking at. But we can go ahead and we can place one right here anyways. We'll select by browser, that's the one I want, and we'll say, yep, that's it. Put it in here right there. So, you know, you guys have never done this before, you kind of get an idea how this works. You put in a component, you put in the next one, you put in the next one, so on and so on. But now that you've got the component placed, what you can do is get over the top of it here, hit E for edit. Here's all the things that we could change about it, and then right here is what we're after. This is showing us a little bit of our 3D viewer, what we just saw. This is what it currently looks like. And then you go add the 3D shape. Now we need to find it. It's hiding in here, so it goes to your library, and I stashed it over in a different folder. Ultimately, you want to put this in with yours. I think I might even still have one here, but I made like a My Library in here somewhere. I don't have it there currently at the moment. I've got it stashed over. Bear with me while I go dig through my computer here. Here it is right here. So you see this? Under the KiCad projects, we've got our TO220, the IGES file that we just exported. And look at that. Boom. There it is in all glory and blazing color, black and sort of white. Look at that. So no conversion, no something into something to get to something else. You just do that. Now when you bring it in, it sort of sticks it off kilter a little bit, but that's okay because it's in line on the X, and we just need to bring the Y forward a little bit. So I thought this, by the way, was kind of funny because the Y works correctly now. If you watch the other video, it goes backwards in the other. So I'm going to bring this up. I think it was about 9.5 that I had before. And if you want to get it to sit just perfect, you can. 9.6, something like that. There's our device. Now, this is also really cool here, I think, because you can see how it's screwed up, right? Now, in the previous video, we went through a lot of talk and conversation on how and where we're going to place all these pins so that we would get lined up with the hole. Well, this is why 3D design and things like this are so great. I feel that we have a hell of a lot more abilities for controlling dimensions in Fusion 360 than we do in the KiCad PCB software, as far as like placing things. Placing things are fine, but when it comes down to trying to decide, what a bend radius is going to look like with a part, I can look at this in 3D and go, yeah, that looks pretty good. And everything in here was to spec, but somehow or another, something I did in the last video is really not in spec. It looks like the body's fitting okay, but the tab and the hole is just out of control. So that'll have to get fixed before I can actually go ahead and use this on a circuit board. But that is the end goal here. That's the point. So that's how you go about making yourself a 3D shape and importing it in to KiCad. So now whenever you're done here and you wire everything all together, you can come up to your viewer and it will show you your circuit board with your component placed on it. Extraordinarily cool. So this will give me and a lot of other people I know a lot of things to do when you're looking for, as I said before, looking for something to practice your 3D design skills. Well, there's a whole lot of electronic components out there that probably would stand to have a lot better version created for them. Okay, so the next video is probably coming up in this, in the KiCad series, is I am going to route this out. We're going to make this into a tiny board because I mandated the students of the world to make a 1" by 1" square circuit board and send it out to get it printed. I'm recommending going to Oshpark because it's probably going to be the cheapest. It's all pretty cheap, but if you go to somewhere like Seed Studios or JLC PCB, I think they're both 10 minimum, and it's going to be about $25. I know, not break at the bank, but if you go to Oshpark, if we keep it under 1" square, you'll get 3, and it will cost you $5. I think it's maybe $1.50 shipping, so maybe $7, and you'll get your 3. So that's what I'm going to do next. I'm going to route this circuit out, and now that I got my cute little 3D design here, I'll be able to show that off as well, and probably a lot of the other components that we'll be adding in, which will end up being ultimately probably LEDs and some resistors. So give that a shot. Thanks.